NEC 210.11c4 addresses the maximum number of receptacles or outlets permitted on the load side of a ground fault circuit interrupter, or GFCI. Specifically, the number of receptacles or outlets on the load side of each GFCI shall not exceed 12. This requirement applies to both residential and commercial installations. When determining the maximum number of 120 volts 20 amp GFCI receptacles on a 20 amp circuit, it is crucial to adhere to this code requirement. The code doesn't limit the number of standard receptacles on a 20 amp circuit based on receptacle count. Instead, it limits based on load. However, with GFCI receptacles, the code places a specific limit of 12 devices. Firstly, let's define what a GFCI receptacle is. A GFCI receptacle is a type of electrical outlet that is designed to protect individuals from electrical shock. It works by monitoring the current flowing into and out of a device plugged into the receptacle. If there is an imbalance in the current, indicating a leakage of current to ground, the GFCI will quickly trip and cut off the power supply. This tripping action occurs within milliseconds, providing a crucial layer of protection against electrical hazards. Secondly, let's delve into why GFCI protection is so important. Electrical shocks can occur when a person comes into contact with a live electrical wire or a faulty appliance. The severity of the shock can range from a mild tingle to a fatal electrocution. GFCI receptacles are particularly important in areas where there is a higher risk of electrical shock, such as bathrooms, kitchens, laundry rooms, and outdoor locations. These areas are often damp or wet, which increases the conductivity of electricity and the likelihood of a shock. Thirdly, let's examine the specific requirements for GFCI protection in commercial installations. While the NEC mandates GFCI protection in many residential locations, the requirements for commercial installations can vary depending on the specific application and the occupancy type. In general, GFCI protection is required in commercial locations where there is a significant risk of electrical shock, such as in wet or damp locations, near swimming pools or spas, and in areas where portable electrical tools are used. Fourthly, let's focus on the implications of NEC 210.11c4 for commercial installations. This section of the NEC places a limit on the number of receptacles or outlets that can be connected to a single GFCI device. This limit is set at 12. This means that in a commercial installation, you cannot have more than 12 receptacles or outlets on the load side of a single GFCI. Fifthly, consider the rationale behind this limitation. The purpose of limiting the number of receptacles or outlets on a GFCI is to ensure that the GFCI can effectively protect all of the devices connected to it. If too many devices are connected to a single GFCI, the GFCI may not be able to detect a ground fault quickly enough, or it may become overloaded and fail to trip. This can increase the risk of electrical shock. Sixthly, let's discuss how to apply this rule in practice. When designing an electrical system for a commercial installation, it is essential to carefully consider the number of receptacles or outlets that will be required in each area. If the number of receptacles or outlets exceeds 12, you will need to install multiple GFCIs to provide adequate protection. Each GFCI should be connected to a separate circuit, and each circuit should have a maximum of 12 receptacles or outlets. Seventhly, let's explore some of the factors that can influence the number of receptacles or outlets required in a commercial installation. These factors can include the size of the space, the type of business, the number of employees, and the types of equipment used. For example, a large office building with many employees will likely require more receptacles or outlets than a small retail store. Similarly, a restaurant kitchen will likely require more receptacles or outlets than a waiting area. Eighthly, let's address the question of whether it is permissible to use multi-outlet assemblies in conjunction with GFCI protection. A multi-outlet assembly is a type of electrical device that consists of multiple receptacles or outlets mounted on a single strip. These assemblies are often used in commercial settings to provide a convenient way to power multiple devices from a single location. When using multi-outlet assemblies, it is important to ensure that each assembly is protected by a GFCI. If the assembly has more than 12 receptacles or outlets, it will need to be connected to multiple GFCIs. Now let's consider the impact of this code requirement on the cost of electrical installations. Installing multiple GFCIs can increase the cost of an electrical installation, as GFCI receptacles are typically more expensive than standard receptacles. However, the added cost is justified by the increased level of safety that GFCI protection provides. Electrical safety is a paramount concern, and investing in GFCI protection is a wise decision that can help to prevent electrical shocks and save lives. 10th, let's discuss the importance of proper GFCI testing and maintenance. GFCI receptacles should be tested regularly to ensure that they are functioning correctly. The NEC recommends testing GFCIs monthly by pressing the test button on the receptacle. If the GFCI does not trip when the test button is pressed, it should be replaced immediately. In addition to regular testing, GFCI receptacles should also be inspected periodically for any signs of damage or wear. If a GFCI receptacle is damaged, it should be replaced immediately. 11th, understand that local codes or regulations might impose stricter limitations than the NEC. Always consult the relevant authorities having jurisdiction to ensure full compliance. It is crucial to verify with the local inspector if there are additional local code modifications to consider in the specific Logan, Utah area. Always consult the most recent edition of the NEC and any applicable local codes to ensure compliance. The electrical codes are subject to change, and it is the responsibility of the installer to stay up to date on the latest requirements. Furthermore, always employ qualified and licensed electricians for electrical installations. Working with electricity can be dangerous, and it is essential to have the expertise of a qualified professional to ensure that the work is done safely and correctly. In summary, when installing 120 volts 20 amp GFCI receptacles in a commercial installation, remember that the NEC limits the number of receptacles or outlets on the load side of each GFCI to 12. This requirement is intended to ensure that the GFCI can effectively protect all of the devices connected to it and prevent electrical shocks. Adhering to this code requirement is essential for ensuring the safety of employees, customers, and the public. Always consult the NEC and any applicable local codes to ensure compliance. The NEC is a comprehensive set of standards, and it is crucial to understand and follow all of the applicable requirements. Also, consider the specific electrical needs of your commercial space. Different businesses have different electrical requirements, and it is important to design an electrical system that meets those needs. Work with a qualified electrician to assess your electrical needs and develop a plan that is both safe and efficient. Remember that electrical safety is a shared responsibility. Employers, employees, and the public all have a role to play in preventing electrical shocks. By following the NEC and other safety guidelines, we can create a safer environment for everyone. Also, regular inspections of electrical systems and equipment are crucial. Inspections can help to identify potential hazards and prevent accidents before they occur. Develop a regular inspection schedule and ensure that all electrical systems and equipment are inspected by a qualified professional. Furthermore, employee training is essential for electrical safety. Employees should be trained on how to identify and avoid electrical hazards. They should also be trained on how to use electrical equipment safely. Provide regular training sessions to keep employees up to date on the latest safety procedures. In addition to the NEC, there are other organizations that provide guidance on electrical safety. These organizations include the Occupational Safety and Health Administration, or OSHA, and the National Fire Protection Association, or NFPA. Familiarize yourself with the resources and guidelines provided by these organizations. Also, be aware of the potential for arc flash hazards in commercial electrical systems. An arc flash is a dangerous electrical explosion that can occur when there is a short circuit in an electrical system. Arc flashes can cause severe burns, injuries, and even death. Take steps to protect yourself from arc flash hazards, such as wearing appropriate personal protective equipment, or PPE, and following safe work practices. Lastly, consider the energy efficiency of your electrical system. Energy-efficient electrical systems can save money on electricity bills and reduce your environmental impact. When designing or upgrading your electrical system, consider using energy-efficient lighting, appliances, and equipment. By following these guidelines, you can ensure that your commercial electrical installation is safe, code-compliant, and energy-efficient. Always prioritize safety and consult with qualified professionals to ensure that the work is done correctly. The combination of GFCI protection, adherence to the NEC regular inspections, employee training, and energy-efficient practices will contribute to a safer and more sustainable electrical environment for your business.